using ESP32 Delegate V1 and the Blink application. Let's talk about this pin and the devices that I use to create this pin. Firstly, I use two ultrasonic sensors. The first is used to see if the user hand or leg is within the range that I have defined. After detection, the servo motor will immediately open to place that hash within and close the bin for users. Next, the second is used to count the amount of waste inside it, and it will show on the LCD and the Blink application. In conclusion, I use two ultrasonic sensors, one servo motor, one LCD 16x2 with I2C, breadboard and jumper valves. Now it's time to demonstrate how to make this circuit. Firstly, LCD has 4 legs. The brown wire is ground, the red wire is VCC, the green wire is SDA, the last wire is SCL. This circuit has many devices. Each device has a VCC and ground leg that need to connect with the V-in and ground leg of ESP32. Therefore, I will use two jumper valves. The white valve connects the ESP32's V-in leg to the breadboard's positive side. On the other hand, the black valve connects the ESP32 ground leg to the breadboard's negative side. SDA will wire with ESP32 pin 21. By contrast, SCL wire with ESP32 pin 22. The white wire connects the ESP32's V-in leg to the breadboard's positive side. On the other hand, the black wire connects the ESP32's ground leg to the breadboard's negative side. The trigger valve will then be connected to pin 5 of the ESP32, and the echo valve will be connected to pin 19 of the ESP32. There are 4 legs for the first ultrasonic. The white valve represents VCC, whereas the black valve represents ground. Moreover, the purple and the red valve are triggers and echo respectively. Now the second ultrasonic also has 4 legs, same as the first ultrasonic. The white VCC valve of this ultrasonic will connect to the positive side of the breadboard, while the gray ground will link to the negative side of the breadboard. The trigger valve will connect to pin 14 of the ESP32. Lastly, the echo pin of the ultrasonic will link to the pin 12 of the ESP32. The final device is the servo motor that consists of 3 valves: ground, power, and control signal. Ground is represented by the brown valve, while power is represented by the red valve. The control signal is connected to the yellow valve. Connect the ground and VCC valves to the negative and positive sides of the breadboard, respectively, as with the other devices. Then connect the control signal valve to the ESP32's pin 13. Trident TD_line notify is a library for line notify. When you go to the line notify the website, you will get a line token. The template ID of the product is used to determine whether a new device is permitted to interact with the product settings. Find a string in the Arduino ID sketch that contains #define Blink template ID. Next, you should define your device names. In my case, I use ESP32, so I define as ESP32. When you use the Blink website, you will get the blink token, so you can put the code in this line. Blink print serial is simply a reload of built-in blink status prints, such as the ASCII logo and timestamp message, such as connecting to. Wi-Fi.h allows the Arduino Wi-Fi shell to connect to a network. Wi-Fi client builds a client that can connect to an internet IP address and port given by the client. Child SSID and child PSS is for connecting to the user's Wi-Fi. Liquid Crystal _I2C.h is a library for LCD with I2C. In this case, I used LCD 16x2. Before displaying text on the LCD, you need to find the LCD I2C address. My LCD address is 0x27. Rx is a parameter that I use to count time when the lid of the bin is open. NewPin is a library that simplifies the use of ultrasonic sensors. For the first ultrasonic, the trigger valve will then be connected to pin 5 of the ESP32. The echo valve will be connected to pin 19 of the ESP32. For the second ultrasonic, the trigger valve will connect to pin 14 of the ESP32. Lastly, the echo pin of the ultrasonic will link to the pin 12 of the ESP32. I set distance 1 and 2 variables because I have two ultrasonic sensors. We need to define the max distance variable when we use this new pin library, so I set it as 200 for both distance 1 and 2. New pin setup of pins and maximum distance. We use servo, so we need servo.h, which is a library of servo. Int post equals 0 means I set the first value of position of servo model is 0. True or false are the only two possible values of a bool. To interpret incoming data as integer, I use param.as_int. Blink write is a function called every time device gets an update of virtual pin value from the server or app. V10 is a data stream of the switch. If pin value is equal to 1, that means the switch is on. On the other hand, pin value is equal to 0, means that switch is off. Blink virtual write is to send data which is map distance to virtual pin 100. Invoice setup. My servo.attach13 is to tell that I connect control signal valve of servo to pin 13 of ESP32. In addition, it will open LCD and show smart bin text and library secret text in one time. Time.setInterval. This tells the blink timer library that I want to call the myTime event function once every 1000 milliseconds. In addition, line.notify. It will send this word in the line notification. Blink virtual light V10 and 1 is to send data to virtual pin 10, that is 1. It means that switch already turned on. In while loop, if the check is true, it will continue to run to the ultrasonic function. On the other hand, if the check is false, the LCD won't show any text. Sonar.pin_cm means we will get the distance in centimeters. The first condition is when the distance 1 is greater than or equal to 1, it will print the distance on the serial monitor. And another condition, distance 1 is less than or equal to 10, the servo will rotate from 0 degree to 180 degree. To open the lid, the lid will remain open in 5 seconds after the servo has rotated 180 degrees, as shown in the Rx variable. After 5 seconds, servo will rotate back from
180 degree to 0 degree. For closing the lid, on the serial monitor it will show the degree and the word done continuously. The distance tool represents the second ultrasonic sensor that is inside the bin. A map is a function that converts a number from one range to another. A value of font low would be transferred to low. A value of font high would be mapped to high, and values in the middle would be mapped to values in the middle. So when the distance tool is following this condition, distance tool is the number to map. 17 is the lower bound of the value current range. 2 is the upper bound of the value's current range. 0 is the lower bound of the value's target range. And the last one, 100, is the upper bound of the value's target range. When the amount of hash is less than or equal to 20, line notification will send the word which is low hash. If the amount of hash is greater than or equal to 80, line notification will send the text doorway hash.
Now I will show how to create a web and mobile dashboard of the Blink. I use a gauge to show the amount of hash in percent. I name the title of the gauge as Run. I created the data stream as V100. In addition, I also select to change color based on value. For example, when the amount of hash is between 0% to 30%, it will be green color on the gauge. By contrast, if the amount of weight is from 31% to 60%, it will be orange. Moreover, if the amount of hash is more than 61%, it will be red to let the users know that they should throw away their waste.
The next is I select switch for control the LCD. So the data stream of the switch is B10. It is a virtual pin. One value is mean that switch will turn on and 0 means switch will turn off.
When you turn on the LCD on the Blink application and the ultrasonic can detect your hand, the lid will open for you to place your hash inside. The amount of waste will then be presented on the LCD in the same percentage as on the Blink application. Furthermore, users can receive notifications informing them of the amount of their waste on the Line application. There are two cases in which the text should be sent to the users. First, if there is less hash in the bin, the message will send as low hash. But if the rubbish is more than half filled or nearly full, the text will send throw away rubbish.